So now we know how to calculate the size of electrostatic force. But how does it work? How does that positive charge Q1 even know that Q2 is there to react to it? With any force that acts at a distance, we have to talk about fields. In physics, a field is an area where something experiences a force. So, for example, that positive charge Q1 is surrounded by an electric field, and when Q2 is brought into the field, then it experiences a force. So how can we draw the field? We're going to try mapping it out by imagining a little test charge Q0. Our test charges we always count as being positive charges. Now, if we were to put Q0 where it is right now, it feels a force exactly in the opposite direction to the plus Q. If we were to move the test charge around the circle from points 1 to 2 and around to 8, at every point it would feel a force in the exact direction away from the positive charge. And so if we were to map it out with lines indicating the direction of the electric field, it would look like lines radiating away from the circle that is the positive charge in the middle. Note that the places where the field lines are closest shows where the field is strongest, which is just near the surface of the charge. This is the field surrounding a negative charge. You can map it in exactly the same way, and you notice that it looks exactly the same shape, but because our test charge is always positive, then in this case you can see that the force will be exactly towards the charge in the center. And so when we map the field, all of the field lines point towards a negative charge. Now we can compare this electric field to the gravitational field around the Earth. We know that the force on any mass is its weight, W, which equals mg. And g is 9.8 near the surface, but it decreases as you move out from the Earth. G is acceleration due to gravity, but you can also call it gravitational field strength, because G, which is W over m, is the gravitational force per unit of mass, and it's a measure of the field strength at any point near the Earth. The electric field strength, we give the letter capital E, and it is the force per unit of charge in an area surrounding a charge. So we have here the equation E is F over Q naught. That means it is the number of newtons of force a 1 coulomb charge would feel, and so it is measured in newtons per coulomb. The same electric field can produce different forces. We don't see this in gravity because we only ever have gravitational field acting in one way, but in electrostatic forces where you can have positive and negative charges, you can see at the top where we have a positively charged rod that a test charge would feel a force away from the rod, and so we map the electric field direction as pointing away from the rod. If, however, we were to put a negative charge at that point, the field is in the same direction, but the force would be in the opposite direction to the field.